Hello and welcome. Virtual Classroom Seminar number 25. And it's the fourth and for now final seminar of our series, How to Migrate to Oracle Autonomous Database, either serverless or dedicated. But before I talk about what we are going to do today, let me give you a big hug, a virtual hug of course, and a big praise. Oracle DBAs run the world. We told you that before, and we still hope that you come to one of our physical events soon, maybe to Cloud World this year in Las Vegas. You grab a sticker, you put it on your laptop lid, and you show everybody how proud you are to be an Oracle DBA. You're the best. Nothing will work without you. The world would stop turning as soon as you all would stop working. So please show everybody, grab a second sticker, put it in your boss's door, that everybody remembers every morning coming into the office. Oracle DBAs run the world. So thank you for tuning in today. And let me introduce the presenters first. So myself, I'm Mike Dietrich. I run the product management team for database upgrades, migration, and patching. And of course, we take care on a lot of cloud migrations in our daily work as well. Then with me today is Daniel Overby Hansen. So Daniel works out from Denmark, from the Copenhagen area, and Daniel loves auto upgrade. And you'll find a lot of auto upgrade topics on his blog, besides things like GI patching, database patching, how to use auto upgrade, downloading patches, and deploying a complete fresh home. Then we have Rodrigo Jorge working out from Rio de Janeiro in Brazil. And even though Rodrigo is a specialist, of course, in upgrades and all sorts of super complex migrations, Rodrigo is also the automation specialist. He loves to automate things. And he loves ADB. Because when you look at Rodrigo's page, oradiff.oracle.com, you will see that super helpful page is running in ADB since day one. And then we have another specialist here, Alex Zabala from Brazil, but working from Texas in the United States. And Alex loves to troubleshoot things. Whenever there's a complex situation with a customer, Alex likes to come in and help and sort out things. But Alex is also taking care on CPAD from the product management side in our team. And we all blog, so mikedietrich.de.com, dohdatabase.com for Daniel's blog, DBARJ for rodrigogeorge.com.br, and alexzabala.com. So on our blogs, you'll find a lot more information, useful information, step-by-step instructions. Feel free to tune in and check our blogs on a regular basis, or subscribe so you find and get new blog posts right away. So for today, we have again a full package, and we share the slides with you. So our mission for today is we would like to introduce you to how does ADB change a DBA's life. A lot of people fear that autonomous database would remove the DBA's job, which is absolutely not true. It could help you a lot. But there are a few changes you need to be aware of, and our mission for today is to show you some of the most important changes and how some things can really help you in your daily work, in your daily business, working with Oracle Autonomous Database. Slides are shared. You can download them anytime. And if you feel after today you need more, or when you missed the first 3 episodes of this seminar series or anywhere else, you find them on mikedietrich.de.com/videos. We have 25 virtual classroom seminars out there, more than 40 hours of die-hard tech content. And when you click on the links to the seminar, you get to a YouTube video. And underneath the video, in the description, there's always the single chapters, so you can jump directly into the chapter you are really interested in. So feel free to use those seminars and share them with your colleagues as well, please. Yeah, and this brings me right away to the first topic. And Daniel will start guiding you through patching in Oracle Autonomous Database.
Thanks, Mike. It probably does not come as a surprise that I'm a huge fan of patching. So how do I feel about autonomous database when patching is taken care of? Well, that's okay. I like patching. I like OPatch. I like auto upgrade. But there are so many other cool things in autonomous database that, hey, I don't care. Patching is different. As I said, in Autonomous Database, Oracle takes care of patching for you. You don't have to work out the details with OPatch Auto and all that. You can spend your time on some more important things that benefit your business. We'll start by talking about Autonomous Database Serverless. In this context, Oracle has a 2-hour maintenance window every weekend. It is a fixed 2-hour period, but we do still have some jiggle room. So if you prefer a different time frame in the weekend, you can file an SR and we can try to accommodate your needs and move things around a little. In the database, if you want to know about previous and upcoming maintenance operations, you can use the DB notifications view. It has some pretty good information. For instance, the maintenance product column, which tells you which kind of maintenance is planned or has been done on your system. There are 3 different kinds: infrastructure, database, and dictionary. If we start with infrastructure, this would be grid infrastructure through the operating system into the hardware, firmware, network, and all that. We have a less frequent cadence on the infrastructure. We don't have to update that every week. But all that kind of maintenance is rolling. But since we do it rolling, you still need, or your application need, to listen for the fan events and then ensure to drain in due time. Besides that, we have database maintenance, and this is where we provision a new Oracle home, and this runs on a 2-week cadence. This is a rolling operation, so again, you need to react to the fan events and drain in due time. And then finally, we have the dictionary, which is the data patch part. So things are definitely a little different here in Autonomous because we do the Oracle Home part in one weekend and the data patch part the second weekend. When we do dictionary patching, the cloud tooling will first run data patch on the root container. And then the capture replay mechanism will listen or find all the statements needed to replay this data patch action. And we can then replay it on all the pods, all the PDBs in our container database. So things are a little different. We use data patch for part of it and then capture replay. As I said, it runs in a 2-week cadence following the patching of the database side. Now, this kind of maintenance works on the database layer, so there's no rolling maintenance here, but we can fully apply the changes in an online manner. The only exception is if you are trying to use one of the packages that we need to replace, then we will give you a few minutes to finish your work. But if you run a transaction spanning so long that we don't want to wait anymore, well, in the end, we will kill your session so we can kind of complete the maintenance there. Since we patch the database on a 2-week cadence, it is fairly obvious that we don't use the same release updates as you have in a regular Oracle database. Those comes out quarterly, but we patch on a 2-week cadence. In the database, you can use the DBA Cloud Patch Info view, and that'll tell you which patches do we apply. So if you want to know exactly what is in your database, what we have applied in your database recently, you can go to this view and then filter on the patch version column and then find all the bugs and bug text related to those changes that came in. Besides that, if we find a critical vulnerability and we have a patch for that, we will apply that as soon as we can on your database to protect it, even if it means that we have to do it outside of the regular maintenance windows. We also apply the patches on different stages. You as a customer has the option of choosing between the early stage and then the regular stage. But that's not the full picture. On the internal side, we have multiple internal stages which you cannot use, but we validate our patches through a number of stages there. So we ensure that when it hits you on the early stage, we have already done a lot of validation of those patches. If you have an always free instance, it'll be on the early stage as well. And I would recommend that you have some of your environments on the early patch state. Your production databases, your most important databases, you keep that on the regular patch state. That is the end of the testing cycle, you could say. So here you have the most stable database where we have tested the patches over and over again. And this is also the default patch states. All through the process, we are monitoring and we use automatic jobs to monitor the database to ensure that no regression sneaks in. We will look at, for instance, the trace directory and the alert log. And if we start to see, let's imagine an Aura 600, then our automation will pick that up immediately and react on it. We use a feature called automatic incident monitoring, which scans all our serverless environments. When it finds a new issue, it'll then automatically create a bug. This is a screenshot from our internal bug database, and you can see that the bug has been prefixed AIM. So I can see that this is something that our monitoring has detected automatically, created a bug, and then assigned that to a developer so we can start to work on that issue as soon as possible. You decide where in the patch state cycle that your database belongs. You can simply change this from one into the other. That is super simple. This is an example of something that it could look like. You have your database, your production database and your pre-production database that runs on the regular patch cycle. So at the end of the testing cycle, this is the most stable. Your dev and your test environments, you put that on early. So if there is a regression that hits your specific database, you can catch that in those less important systems. If you discover an issue in one of your early patch states, after patching, you should file a service request so we can stop that patch from reaching your production environment or the regular patch state at a later point in time. So react quickly, file a service request, and we will then take care of that for you. Now, some of the things that I really like in Autonomous is this feature where we can automatically test the patches for you. So let's create a new database. We call it patch tests. We keep that on the early patch state. And this specific database is a refreshable clone from your production database. So production runs on the regular patch state, but we create a refreshable clone running on the early patch state. Then we can use database replay to capture the workload on your production database and then replay the same workload on your patch state or patch test database. And we can then detect if there are any issues with your workload on those new patches. And we can automatically repeat that at a given interval. Using this feature is super simple. It's a feature that you can enable with the DBMS Cloud Admin package. You specify the time where you want to capture the workload and for how long, and we will then automatically replay that on the test database that you had, the refreshable clone. Then you can use the DBA capture replay status view. You can monitor that and detect any issues. That was enough about serverless. I'll hand you over to Alex to talk about dedicated.
Thanks, Daniel. It was a great overview about patching on Autonomous Database Serverless. Now, let's talk about patching on Autonomous Database Dedicated. On Autonomous Database Dedicated, the patching is way more flexible. You can define your schedule for patching. You can even skip a quarter for any reason you want to do it, but not 2 consecutive quarters. Security patchings, it's monthly and it will be applied by Oracle when Oracle finds a security issue where the score is equal or greater than 7. The patches, we have the quarterly patches where we are patching the Exadata infrastructure, the VM clusters, and the container database. It includes the release updates. It can be rolling or non-rolling, and you can specify a buffer time between the standby and the primary. For example, you can specify from 1 to 7 days. And it's optional, you can also upgrade your time zone files. Here is a screen where you can define your maintenance. For example, you can choose from rolling or non-rolling. Rolling, one node at a time, no downtime for your application and your users. Non-rolling, it's faster, and if you can afford the downtime, it's a great option. You can enable the time zone updates when you are using the non-rolling. For release update, you can choose to apply the next one or the latest one. For example, your database is now on 19.25 and you want to apply the next one, 19.26, you go for this option. If you want to apply the latest one, and for example the latest one is 19.27, then you can choose the latest release update to be applied. And at the end, you can choose your schedule preference. No preference, or could you choose and schedule for you, or you can create your custom schedule where you can choose the month, the week, the weekday, and the start time for your patching. To check your maintenance history, you have this screen where you can check the component and the type of the patch that were applied and a lot of information about these patches. To check information about the quarterly maintenance patches, you can go to this node 888828.1. Monthly patches. Oracle will give you an advice, a notice 7 days before apply the patches. You have an option to reschedule. You usually have 21 days to apply this patch, and it's not possible to skip. Since it's a security patch, you should really apply the patch. For one-offs, for example, you are facing some issue on your database and you open a service request and Oracle needs to create a one-off patch to fix your bug. So by default, Oracle will apply this one-off in 72 hours after the patch is available, but you can choose to apply this patch immediately. Another thing, and it's very important, the release update for the Autonomous Database Dedicated is not the same release update for regular database. Some general recommendations. Please make sure your application is following the MAA guidelines to not have any downtime on your application. One example, on Autonomous Database Serverless, you cannot change the drain time out. It's by default 5 minutes, but you can change it on Autonomous Database Dedicated. One very important recommendation is to set your maintenance window to an off-peak period, usually weekends or later nights. It will be a good time to apply patching. Another important thing, please use the OCI events to receive notifications about patching when it starts and when it finishes. Now, back to you, Mike.
Thanks, Daniel. Thanks, Alex. This was a good intro into patching. Now, let me change topics a bit and we go to real application testing. So we all know by heart that testing is very important, but we all have seen too often that there's no time, no budget, no plans for proper testing. And something you should be aware, if you don't test, you are likely to fail. So invest a bit of time in your project in the testing. And we have a tool helping you here. This is real application testing. And some of you may have seen or used real application testing already for on-prem upgrades or migrations or for patching, but we can use this also in relation to migrations to Autonomous Database. One thing, everything works great on PowerPoint Of course, it always does. In reality, it may require a little bit of work and adjustments, and a little bit of patience here and there as well. Reapplication testing has two components. SQL Performance Analyzer. The idea is we capture the statements on production and we find the misbehaving ones before go live. We tune them, we treat them well, and no problems from the statement side. The other part is database capture and replay. So we record a full workload and we replay it in Autonomous Database. While SQL Performance Analyzer is non-destructive, meaning it doesn't change your data, it only reads data. Database Capture Replay is destructive. It executes statements, it changes data. So if you use Database Capture Replay, you must be aware that you should be able to go backwards or you rebuild your test environment again because it changed data. Both are an awesome combination and they can help really a lot. Now, SQL Performance Analyzer at first. We have shown this in all details already in our Performance Stability Prescription seminar. So let me recap very briefly for those of you who haven't watched that seminar yet. We collect statements either from AWR or directly from the cursor cache for OLTP applications into a SQL tuning set. Ideally, you capture not just the statements from yesterday morning. Especially with AWR, it's quite easy. Make sure your retention is big enough. Grab 40 days of statements or at least a full month. So monthly ending is in there. When you capture from cursor cache, you may keep it a little bit shorter because there you have way more statements in a SQL tuning set afterwards. Then we migrate our database now to ADB and we make sure that we load that SQL tuning set into our ADB environment. It goes via staging table, simple export, import data pump from that staging table, move it into ADB, and there it is. And now we can play with it. We use the SQL Performance Analyzer to test the workload, meaning it does a test execution of the statements. And then we report on the regress statements. This is one important thing, but based on experience, I would also recommend you to report on the error statements, because when you did restructuring for ADB migrations, then some statements simply may error out, even though the statement may run correctly in reality. So a little bit of a grain of salt need to be added here by reading the results. And this is how it works concept-wise. Let's say we have a 19C database. We have collected the information now from AWR and maybe from the cursor cache into a SQL tuning set, which has now all the information about our statements. Then we do a migration to ADB. And once the migration is completed, now let's say we went to ADB 23i, but it doesn't matter to which ADB we are going. We have all the SQL statements, the binds, the statistics, the execution plans from production in that SQL tuning set. We move that SQL tuning set over, and now we do a test execution. So every statement gets executed multiple times, and then we get the best results out of that. So we have before migration and after migration, and we can compare both to each other based on 6 different metrics: elapsed time, buffer gets, and some others. But elapsed time and buffer gets are the ones I look at typically first. So we compare before, after, we get some ideas. And this is how a typical report looks like. So here you see only 2 statements and you see SQL trial 1. SQL trial 1 is basically what we collected on production. And SQL trial 2 is now the test execution average out result, the median of the executions in ADB. When we look at the distinct statement, and you see on the very, very right side of the slide, the plan is changing. Then I can click on a statement and I see parts of the statement in free text, but I see also the execution plan when I scroll down a bit and the statistics for each of the 6 different categories we can compare before, after. So this is the statistics and this is the execution plan, and we have not only the plan after, but we have also the plan from before, so we quickly see what's happening. When we've done that, we implement some sort of change. Let's say we nail down a SQL profile, or we nail down a SQL plan baseline, or we add a SQL patch. And the good idea of SQL Performance Analyzer is now we can repeat this execution. We have done some treatments, or what we do in ADB migrations quite often, we change the parallel degree because ADB does really a good job. So we change that and then we compare again. And this is how we optimize the individual statements going forward. One thing to keep in mind, there's an underscore parameter because the default setting of 400 for cursor bind capture area size is a little bit low, especially if you bring over complex applications having complex statements using a lot of binds. So my recommendation, or our recommendation, is pull this up to the maximum of 3,999. You can't lift it higher, unfortunately, as of now. So then we tune the regressed plans, or we just rely on ADB, because one of the coolest things in ADB is it can tune such a workload by itself. The other part, database capture replay, is now working the following way. We capture a workload on a source environment. So you define a directory and you capture the workload. Sounds simple? Is very simple. You move the capture files to ADB into the object storage or in your FSS, wherever, and then you replay the workload. There you don't have as many switches to flip around as you have when you do this on-prem, but for a start, this typically works nice. And then we monitor the results and we optimize performance again, either relying on ADB or doing some manual treatments. So another thing where this comes in extremely handy is Oracle Autonomous Database, especially when you are 19C today and you plan to go forward to ADB 23i, it has this super cool feature of refreshable clones. So you may remember from our upgrade seminars, we push refreshable clones a lot. And in ADB, that is implemented as well, allowing you testing. But seeing that you can upgrade to 23 ADB is one thing, and this will work for sure. But the idea is verify performance. So here, especially database capture replay comes in again, because the refreshable clone has everything. You capture a workload, you play or create a refreshable clone going forward, and then you replay that. And you see how it behaves then in 23AI ADB, and this is fully implemented in the console as well. So we have a link to the documentation here on the slide. Feel free to tune in. Now, I show you slides. And you may say, hey, yes, that's cool, let's try. But we had this idea of interviewing somebody who really worked a lot with that. So let me interview here and introduce a friend of ours from the German pre-sales organization, Ulrike Schwinn. Yeah, hi Ulrike. It's a great pleasure to have you here today. We are generally speaking about autonomous database migrations, but you and I, we know each other for such a long time, and I know that you are the real application testing expert.
Wow.
And I'm so happy to have you here today. So before we really start discussing real application testing, can you tell us a little bit more about yourself?
Wow, okay. Thank you for the introduction. I have been with Oracle since 1993, during which I've worked in different departments, locally and internationally, and also with you, as you already mentioned. What did I do? In general, I focus all the time on my passion, that's Oracle Database, converged topics, and of course, real application testing.
Yeah.
I do support customer projects, POCs, do blog and speak at conferences and so on.
Okay, this is amazing, and this is actually why I wanted to have you here today, because you bring all the real world experience. Tell me, what is your opinion about real application testing these days?
Okay, you are wondering if there's an evolution,
Evolution,
what
yes.
the status is and so on.
Yeah.
Yes. Overall, I would say it's about completion or manageability, but I think the main feature or the main topic is that we can use it in autonomous database.
Oh, that's true. I saw that. I
Yeah.
think we announced this a while ago. But from your experience, when you use now real application testing and it has the two components, SQL Performance Analyzer and Capture Replay, How does it work in Autonomous, and how is it different from using it on a regular on-prem environment? Or is there any difference?
Yeah, there is a difference. Two techniques, SQL Performance Analyzer or SPA and the database replay component. SQL Performance Analyzer for the SQL workloads, it's, I would say, the same. If you know how to use SQL tuning sets and you know how to export and import it in your environment, let's say in the autonomous database environment, it should work like on other environments. Perhaps you need to take into account for, let's say, for caching, that you do it twice or something like this. But the component database replay was totally reworked because, as you know, or as all of you know, we have no access to operating system. So how can we start these clients and everything? So the idea is, as usual at Oracle, we introduce a new package. It's the DBMS Cloud family. And there's a DBMS Cloud admin replay package or function you may use. And this one is only one command. And with this one command is doing all the things you usually do in 4 or 5 steps if you use another environment. Meaning it's very, very simple. It's not complex, but that also means it's very limited. Because what you're not able, for example, to filter it, to start the WRC clients, to change the WRC clients, to monitor them. There are lots of things that are not available. So I would say this is very restricted. It's for restricted workloads. And in my opinion, I would start, as usual, is also my recommendation, use SQL Performance Analyzer. I use it before and try to find out how it is in your environment. Database replay is, let's say, limited. It's for limited workloads.
Yeah, you said something which made me really listen up. You said run it twice. And I think you meant this regarding Spark. Can you tell us a bit more why and what you exactly mean with that?
When you compare two SQL tuning sets, meaning the one from let's say on-premise side or from let's say from another environment, so you have the execution statistics and they are cached, meaning the information you get, the SQL statistics, execution statistics are also cached. And if you run it with SQL Performance Analyzer, you do not get with the first run the cache statistics. So if you do it only once and you compare it, you will get a bad result, let's say, for on the autonomous database side. So what you can do with SQL Performance Analyzer and SQL Tuning is that you can choose your SQL tuning sets and compare it with each other. So you can even change something, meaning you can change your table structure underneath or something and can do it the third time. And again, compare the third time or the fourth time with the execution statistics from the other side. So it's quite easy. I have also described it in my blog post, if you read this carefully. And I explain also how to choose to get the right report.
Yeah, I mean, this was also like when I was involved with the first ADB migration, where I asked a customer to do SQL Performance Analyzer because I use it quite often in on-prem projects. I started Googling and I found blog posts, of course, written by you. So you have blog posts out there, but I think you have a little bit more. And are you fine if we share that with customers afterwards?
Yeah, of course. Of course I do. Yes.
And you have the procedures in your Git, so people don't have to reinvent the wheel.
Right. And what I recommend is using the documentation, of course. There's a documentation for the overall functionality and even for autonomous database. There is an autonomous database part for real application testing. So you may, of course, read this one. But if you want to have videos or a script, you can really have the script. You can copy and paste the scripts, or even what you are saying. I have also the scripts on GitHub and also the monitoring script if something goes wrong or something shouldn't, but we know. So they can use it, of course. And it's nice that you share it afterwards.
Yeah, I will definitely, because I a secret, I tell you, I stole some of your scripts as well already because they work so nicely. So we'll share after our interview. Now, a final thing, can you give some recommendations where I say, okay, somebody approaches now an ADB migration and wants to use SQL Performance Analyzer and maybe capture replay as well. What should people really keep in their mind before they start?
Yeah, first of all, it's fine that they test what you already assumed. So don't miss the step testing. So please test. And if you use SPA or database replay, please set expectations. It's like usual testing.
Yeah.
What is the goal of your, what should the report look like? What's the goal of your convincing your management? Or what is it? What is also the timeline? You need a timeline for the testing phase and a learning curve. You need, I have scripts, of course, they can use the script, but there is a learning curve. It's not, it's a technology and you need to learn it somehow, of course. Even if they use Oracle Enterprise Manager, still you need to learn it. And concerning the workload, please really think about the workload. It shouldn't be too big, meaning having a workload 24 hours makes no sense, only if you want to find out if it runs at all. But to judge any performance, it doesn't make any sense. So if you have the chance with capture and also with SQL tuning set, you have the chance to filter, meaning filter it by users, by schemas, or by instance. And discuss with your departments, with the developers or something, what's important or what they did do or what is the peak. So find out what is the important peak, and around this half an hour, 1 hour, let's say, to give a timing so that you can judge afterward what you have done on the one side and on the other side. So this is something I would recommend.
So in final summary, you have made some really good experiences also for ADB migrations already, and you would consider this as absolutely helpful. Thank you so much, Ulrike. It was a great pleasure to have you today here. And for everybody else watching that, please use the scripts, use the blog post, use the documentation. And thanks for your time, Ulrike.
Yeah, and thank you very much for inviting me and that I had the chance to talk about my experience. Thank you, Mike.
Thanks. Bye.
Thank you, Mike. Now in this chapter, we will learn how to enable data pump tracing, but in ADB. So imagine, for example, we have an export or import operation that's stuck and we don't know what's going on. So in this chapter, you will learn how to enable the tracing, generate the trace files, and identifying what are the performance bottlenecks that's happening with data pump to quickly fix it and be able to resume your data pump job. So there are three important things you should collect in data pump to understand what's going on. The first one is the data pump log file. The data pump log file contents is the same thing you have spooled to your screen when you call XPDP or InPDP, for example. The second thing that can help you is the AWR report. So you can take 2 snapshots before and just after your data pump job finishes. And reading the AWR report, you can try to understand what is going on and the most performance impacting cycles that executed during this period. And finally, data pump trace files. So we can enable data pump tracing. We will see how in a few slides. And with this tracing, we will have on the trace files everything that happened in the controller and worker process in a much more details. And usually this is for support when it's requested. We also have this doc ID, which is 28649.6.1. And here we explain in details what is the trace parameter that you can provide to data pump and what it changes during the execution of a data pump job. So now let's go with the AWR report part that will help us identify any possible performance bottleneck cycles that are executing on the database. The first thing you should do is modify the snapshot settings to every 15 minutes because the default interval of 60 minutes is too high for a data pump job operation. So change it to 15 minutes and take the first snapshot. Now you call your data pump job. We recommend you to provide this matrix equal to yes and log file equal to all, so you have much more details in what's going on in your log file. However, also enable the tracing. So when you provide this trace equal to 1FF0300, this is not a magic value. Again, on this doc ID that I mentioned before, we explain this trace parameter and what it enables on the data pump when you provide that value. So we recommend you to provide that, and that way we will generate a trace file for data pump. And finally, after your job finishes, put the interval back to the original value, which is probably an hour. And finally, take a final snapshot after the job finishes. So now you have 2 snapshots to get everything that happened in the betweens. In ADB, you don't have access to Oracle Home and to the RDMS admin AWR rpty.sql file that could help you generate an AWR report. So in ADB, the way we need to generate an AWR report is using SQL. So there is this DBMS workload repository.awr report HTML function. This is a pipeline function that will return a table. So the contents and the output of this SQL will be your HTML file. So you can run this SQL, you copy all the output, you paste it on a file, you save as HTML, and then you can open it in your browser. The parameters for this SQL can be gathered using the following queries that we have here at the bottom of this slide. This was for AWR. Now, if you want to get the data pump tracing file, how we do that if we don't have access to the DIAC directory of this ADB compute? So the way for doing that is creating this VDOR DIAC trace file view. This will give you all the files that we have in your PDB DIAC directory. And after you identify which was the file that was generated by data pump, you can go to this next view, which is the DIAC trace file contents, providing the name of the trace file. And on the payload column, you will have in each of one row for each line of this file. So again, you can copy the output of this SQL, save in a text file, and now you have access to the trace file that was generated inside the PDB of this autonomous database. So the load file content that we have on the load file parameter of data pump is the same that you have on the screen when you have an attached job and call, for example, XPDP or MPDP. However, there are also other ways for gathering this file. First thing, imagine you don't have access to any directory in this ADB. So you can provide this no-load file equal to S command line option. And that way you can call data pump even without any access to any directory. You could read, for example, the dump file from an object storage and do not generate any log file. And that way, for example, it's possible to execute data pump without a directory permission in ADB. But imagine you have access to a directory, you generate a log file there, and now you want to read the contents. Again, the contents will be the same you have on the screen when you call data pump with XPDP or MPDP. But if you still want to have access to this file because maybe you run this data pump job as a scheduler job and you don't have access to the output, or maybe the output was so huge that it was truncated in your stream, then there are multiple ways. First, you could use UTL file get line plus DBMS output put line to print the contents of this file on the screen again. Or you could move this file and download it from object storage using DBMS Cloud. And finally, my favorite method is using SQLCL with JavaScript, and then you can read this file, put it in a blob, and then SQLCL can save this blob as a file in your local file system. One thing to have attention is that the default max DIAC size for our autonomous database PDB is 100 megabytes. So this is controlled so the multiple PDBs we have sharing the same container in the serverless environment, they don't overload the file system. So the output may be truncated. Also, it's important to notice that if you don't have one of the following grants, you will not generate any trace file at all. So no trace file is generated. The code of data pump will check if the exporting user or importing user has any of those permissions on those roles before creating the trace file. You can also open an SR in case the trace file is truncated and request a temporary increase on the max diet size for your autonomous database. And usually that's what I do when I need to troubleshoot some of the jobs and the file is truncated, so I ask for a temporary raise to 10 gigabytes. And finally, there is also a way for generating even more SQL traces in case you are still not identifying what the problem of your data pump job is. So you can also request some SQL trace and also this trace 39089. So that way, data pump job will create another kind of traces that will help support team to identify the issues with your job. Now back to you, Mike, with some tips and tricks.
Thanks, Rodrigo. We talked so much about data pump. I think you all must be data pump experts by now. I have a few tips and tricks for you. So, what is your interface to a database in ADB? The easiest one is really in database action. So when you go in your web browser to your ADB environment and there's a tab, database actions, and this is where we are going to start with. Because here you find everything you typically need for an ADB administration. Let me start with the development section at first, because we all love to type a few statements. SQL Worksheet is your interface, and this is here already as well under SQL. Just first place, first tab. Here we go. But there's more here. Also a good interface to DBMS scheduler. So this allows you to administer jobs, monitor them, and so forth. So this is super, super helpful. And I think personally much easier than going down into the views. Let's go further to administration, the next tab. Here you can administer your users. You create users, you change passwords, you add or change, adjust quotas, all these things. Super easy, super quick, very helpful. And there's also an interface on the same tab for, yes, data pump. Even though you all are data pump experts by now, you can work with data pump here from this graphical interface as well. Then let's go to monitoring, because this is actually where I spend the most time on when we have real projects. We want to monitor, and it first starts in the performance hub. So here we get all the information about overall performance, but we can also drill down in SQL monitoring and see all the individual statements, the execution plans and such. So this is really a thing you should be familiar with and you should make yourself familiar with. But there's also the database dashboard with some overall statistics and useful information around your ADB deployment as well. Super cool, but there's more. You know SQL Developer, most of you use SQL Developer, and there's a new tool out there from Microsoft called Visual Studio Code. And in this tool, actually, we allow to have a plugin for SQL Developer. And when you have this plugin here, this is how it looks like. So on the left side of the screen, you see the typical format of all the items in SQL Developer, like your database connections, and then as soon as you click on a database, you get the tables and whatever you need to know about your database, as you know that from the standalone tool. So this is actually the future of SQL Developer. And what I'm doing here is I would like to create a new connection to my ADB2. And in ADB, we offer you just the wallet as a zip file. So if you download the wallet, and you just click here and choose that wallet file, you immediately have all the connections in there. Some of you may know this already from the regular SQL Developer, because there it works the same way. But this is here the SQL Developer in Visual Studio Code. And here you can do this easily as well. And you have your SQL Developer items immediately there. Another useful view here in the database is $PDBs. You may know this as well already, but here in this context, there's one very important column, and it's called cloud_identity. You see it already on my slide. It's JSON format, but it has things like if you're on serverless or dedicated, which service you're using here in this case, in this example, ADW, but also which options or components are configured and available on the web page, like Graph or Apex is configured here, OML, and so on. You see if you have auto scaling on and lots more. We just cut it off here because that slide has just endless space. But please have a look in here, super useful to access this view and this column here. And yeah, hopefully many of you use Armen to back up your databases. And one additional benefit of using ADB is actually Armen in most cases has a repository database. And it's a database. It needs resources, you need to administer it, and so on and so on. Why not putting in ADB? Have your Armen repository database in ADB. Cool documentation. Look it up when you download the slides. And in a few minutes, your Armen repository has been migrated to ADB. And then you don't care about this administration anymore. Can be very helpful. And with this, I would like to hand over now to Alex to go into some super cool ADB features you can turn on at will. Alex, your turn.
Thanks, Mike. These were great tips and tricks. Let's talk about some very important ADB features now. You cannot create table space in Autonomous Database Serverless, but on Autonomous Database Dedicated, you can't. But be aware of a few things. For example, if you create a table space using dictionary managed, it will be converted to locally managed. If you create using manual space allocation, it will be converted to ASSM. And if you use the uniform extended allocation, it will be converted to auto allocation. Another thing, if you try to create a small file table space, it will be converted to a big file table space. But don't worry, no change to your application. Oracle Autonomous Database will handle everything internally. Automatic indexing. When we are talking about indexes, indexes are critical for SQL performance. But to create manually an index, I need to understand my application. I need to know my schema, my SQLs, and every index that I created, I'm adding some overhead to my DML operations. And the problem is, over the time, my workload can change. So for example, some tables can grow more than others, and I need to recreate some indexes. To help with this on the Autonomous Database, I can use the automatic indexing feature. It's a Exadata feature. It's disabled by default, but I can enable and use on the Autonomous Database. What the feature does, it basically monitor my workload, and then it can automatically identify the indexing opportunities. It will create and drop indexes. So it basically maintains and adapts my index over the time. Some options that I have, I can set the auto index mode to implement. So in this case, I'm telling the Oracle database, okay, I trust in your decisions. Go ahead, analyze my workload, and do everything, create, drop, and maintain all my index automatically. One thing to be aware of, if I have JSON data, there are some restrictions on ADB. So please go ahead on the documentation for your current version and check these restrictions. Another option that I have is to set the auto index mode to report only. So in this case, I can generate a report, and then I can analyze this report and decide the index that I need to create or drop or change. Automatic partition. This is another great feature for Autonomous Database. It works similar to automatic index, but for partitions. It will analyze my workload, and it will suggest some partition methods for tables and indexes. Partition methods that I can use today is automatic interval, list, automatic, and hash. But be aware, as of today, it supports only single column and single level partition. How the feature works, again, it will analyze my workload, it will identify the tables, it will evaluate the partition strategies, and then it can recommend, or it can also implement all these strategies. The difference between for the automatic indexing, it's I need to call manually this package, and I need to call the recommended partition method manually. One example, I can set the auto partition mode to implement, and again, I'm saying, okay, Oracle, I trust in you, go ahead and do your magic. Or I can set it to report only. When I set to implement and I call the recommended partition method, Oracle will do everything for me. It will partition my index in my tables, and then I can check later this view, or I can generate the report to see all the changes. When I set to report only, then I can generate the report, analyze the changes, and then I can implement one by one. I don't need to do it for my entire database. I can do it, for example, for just one table. And another good thing from this feature, for example, I'm running this in production. I can get the DDL from my production and use this DDL to apply in all my other database like development, UAT, testing, and so on. Fast ingest. This is a great feature when I have a lot of inserts, and when I say a lot, it's really a lot of inserts, like millions, billions, or even more. It's commonly used when I have IoT devices. When I should use it, when ACID is not mandatory for my application, when I should avoid it, if I have, for example, OLTP style application where I cannot lose any transaction, then I should not use this. To enable this feature, I can set the optimizer ignore hints to false. Then I create a table. There are a few restrictions on the table that I can create. For example, certain type of constraints, I cannot have triggers, and so on. Please check the documentation for your version, because on 23AI, a lot of these restrictions were lifted. And last but not least, then I use this hint on my insert command. Here, a quick example. I'm creating a table. I'm setting this table to mem optimize for write, and then on my insert statements, I add this hint. So that's all from my side for fast ingest. Now back to you, Daniel.
Thank you, Alex. Those were some pretty cool features. My own favorite is fast ingest. That is so cool. What is also so cool? Statistics. Everyone loves statistics, right? So let's dive into the details. In Dedicated, it is very simple. Statistics works just like any other Exadata system. You don't have to worry much. You can use the DBMS AutoStat executions view to see what is going on in your database about automatic statistics gathering. You have the regular auto task which runs in the database maintenance window every night or every weekend. And then on top of that, since we are on an Exadata platform, we also have high frequency statistics gathering, which I will cover in just a second. In serverless, things are a little different. We are introducing new ways of gathering statistics. If you have a data warehouse configuration in Autonomous Database Serverless, we do not use the automatic statistics gathering, so that job that runs in your database maintenance window. Why is that when statistics are so important? Well, in a typical data warehouse configuration, you are loading in a lot of data. After loading that data, you don't have any DML, or DMLs are infrequent. You don't do many insert, update, or deletes after you've inserted those new data. So regathering statistics in your maintenance window, that is a waste of resources. It doesn't fit that well with a typical data warehouse load. In contrast, after your direct load operations, the database itself will regather those statistics when needed. So you don't have to worry about it. We will take care of that during loading. But if you then do some conventional DML, well, then you need to gather statistics on those affected objects. In transaction processing, you have a typical OLTP workload, so a lot of DMLs. So in this configuration in serverless, we still have the automatic statistics gathering job. But the views, the DBA obstat and the DBA auto task views, they do not exist, or they are disabled in serverless, so you cannot use those to get information about statistics gathering. So instead, you need to use the DBMA tab statistics and related views to find out when is the database gathering these new statistics. On Exadata, we have this feature called high-frequency statistics gathering, which is complementing the normal automatic statistics gathering job. We have that on the autonomous databases, dedicated and serverless as well. High-frequency statistics gathering is a lightweight task that is complementing and running more often than the automatic statistics gathering. It'll look for objects with stale statistics, and when they find it, it'll then regather statistics so you don't have to wait until the following maintenance window where we can run the big automatic statistics gathering job. So this is a complement taking care of things as we move along. In the DBMS stats package, you can find information about high-frequency statistics gathering, and by default, it'll run every 15 minutes looking for objects with stale statistics and then regathering on those objects as well. There is an additional view in the database where you can find information about these high-frequency statistics gathering run, and you can see if they actually did anything and for how long did they actually run. On top of that, we have real-time statistics gathering. This is also an Exadata feature that you have access to in Autonomous Database. High-frequency statistics gathering is enabled by default. Real-time statistics, that is an option that you decide whether you want to turn on or not. It is disabled by default. This augments additional statistics collection, and if you turn it on, when you do DML in your database, insert, update, delete, well then the database can update some of the basic statistics as part of that DML. So imagine that you insert new rows. If you insert 10 new rows, we can then increment the number of rows in statistics, or if we add new blocks to the table, we can update those statistics as well. But from my point of view, the biggest benefit is that we can actually also update the high and low values of a column. So sometimes you have columns that you enter that is continually incrementing. It could be a date, it could also be something from a sequence. Every time you insert, you generate new high values. This means that all the new data will be outside the bounds of the high and low values according to statistics, and in some cases this can lead to some really bad cardinality misestimates. If you have such a workload, well then real-time statistics can be a huge benefit because we can update high and low value as we insert or update the data. You can very easily turn this feature on in Dedicated and in Serverless. There's an instance parameter that you can use, and then everything happens automatically by the database. That was about statistics on user objects, but we also know that statistics in the dictionary is very important, and the automatic statistics gathering job is also taking care of the dictionary statistics. You, as a user, you don't have privileges to regather just the dictionary statistics. It runs as part of the automatic statistics gathering. If you end up in a situation where you need to rephrase statistics in the dictionary, you need to file a service request, and we will then take care of that for you. It's also good to know that in serverless, we will have histograms on all columns. This is different than the default. In Dedicated, we are using the default, which is that we only create histograms on columns if we can see from your workload that it is needed there. We use information about predicates and joins to determine where we actually need histograms. But in serverless, as I said, we have histograms everywhere. This is of course a big benefit when we need to come up with a new plan, but it can actually take some time to create the histograms or calculate the histograms for all the columns. So if you have specific tables where you want to disable the histograms, you can set a table preference and set the value to for all columns size 1, which effectively will disable histograms for just that columns. Statistics is very related to performance, so I'll hand you over to Rodrigo to talk about some other aspects of good performance in your database. Take it away, Rodrigo.
Thank you, Daniel. Now that we heard about statistics, let's go into the topic that's the favorite one among all of us DBAs, which is performance. Yes, you guessed it right. So let's go into the performance topic. First of all, in Autonomous Data Warehouse, we totally ignore all the optimizer hands, including the parallel one. This applies for the serverless and dedicated in ADW. We don't do that for ADB. The way we control that is using those two parameters which default to true in ADW but default to false in ADB, which is the optimize ignore hands and optimize ignore parallel hands. However, you can note that those parameters are session modifiable. So if you want to use your hands on ADW, you need to do an altered session and modify them to false instead of true. And again, in ATP, those parameters, they default to false, meaning you can use your hands, including the parallel one. So in ADB, we use SQL plan managements to increase the plan stability. Let's do a quick recap to show you how this SQL plan management works. So first of all, imagine you have a given SQL statement. The first time this SQL executes, it's gonna produce a plan. This plan can be good or can be bad. The thing is, on the second time that this SQL executes, if it produces a different plan, what the SQL plan management will do is not use this plan. Instead, it will use the original plan. And this plan will be put on hold for evaluation. So now it comes the second part, which is the evolution part. So this plan evolution typically run as a manual or maintenance job. So usually the default for that is once a day, usually during the evening. And this job will test the other plans which are still not accepted and see if their performance is better than the ones that are currently accepted for a given SQL. And if the plan is better, then it's gonna be marked as accepted. So the next time this SQL executes again, now it's gonna take the best accepted plan and use it for that SQL statement, okay? So the good thing is that now we have a known performance because any SQL that could potentially be bad for your database will be first tested before it's accepted. So you have a predictable and stable performance in your environment. So this is what we already know as SQL plan management. What Autonomous Databases Dedicated uses is the automatic SQL plan management. So the difference here is that it does a background verification of your SQLs during the evolution phase. So differently from the former method where we usually test your SQLs during a manual or maintenance window, here it goes through a background process. So this background process is differently because it runs every 15 minutes instead of once a day during the maintenance window. So every time you produce a new plan, usually after 15 minutes, this plan will already be evaluated. And in case you have a better performance, this plan will be marked as accepted. And the next time this SQL executes again, it's gonna use that better plan. So now we went from once a day to 4 times an hour, 1 time every 15 minutes. What the Autonomous Database Serverless uses is not the automatic SQL plan management, it's something that's even better. It's an evolution that we call real-time SQL plan management. This was introduced in 23AI, but we backported that for the 19C on Autonomous Database. So if you have ADB in either 19C or 23AI flavors, you will have this feature. And the difference here is that instead of running this check as a background job that was running once every 15 minutes, now it's a foreground job. So as soon as your SQL finishes executing for the second time, where it produces the new plan, this plan will already be checked if the time is better or worse of the past plans you have. And in case you have a worse plan, it's gonna be put as a side. If it's a better plan, then you will mark it as accepted straight away. So now we went from once every 15 minutes to almost in real time. So usually if you have a SQL that executes every 2 seconds, for example, the second execution, we already get the better plan. Okay, so that's an evolution. Again, it's enabled in Autonomous Database Serverless, and if you want to have it enabled in the Dedicated, is also possible, but you have to manually enable it. The SQL plan management features, they are supported because of the automatic SQL tuning set. The automatic SQL tuning set, we also call it ASTS. It's something that we have in Autonomous Database, and this is already enabled. And it's different from AWR because here in this feature, we will collect all the statements you execute in your database and put it on this SQL tuning set. While in AWR, it gets from Ash, and Ash has some metrics for getting a query differently from the automatic SQL tuning set, which will get all the queries. The only exception for the automatic SQL tuning set is those queries with literals, because if you have a query with so many literals and running over and over again, generating a different SQL ID, then it's gonna restrict only for 100 different queries to collect for a force matching hash, okay? As we have been saying for the past 15 years, for the SQL plan management to work well, you need to use binds in your application. If you don't use binds, if you use literals, if you still use literals, you can go with SQL patches or SQL profile, and SQL profile you have the force matching capability for specifying a SQL profile for queries that has literals inside. In case you use some of those SQL performance features at the same time, like SQL patch, SQL plan baselines, and SQL profile, it's also important to know which one takes priority over the other. So SQL patch is always the top priority in this list, meaning, for example, if for the same SQL statement you have a baseline but also have a SQL patch, the SQL patch will be used. The best thing you can use in Autonomous Database to measure and monitor the performance is the Performance Hub, which is available under the Database Actions, which is available for any Autonomous Database. Even the Autonomous Database deployed as a container that you can have in your on-premises systems for testing. The way it works is you open the Database Actions, you click on the Performance Hub, and here on the top you can see this slider when you can select a time frame, and also you select this time frame at the bottom of the page. You have the SQL monitoring section where you have all the currently executing SQL statements and their SQL IDs, their plan hash, the username who is running them, the number of parallel slaves they have, the database time IO, and even the SQL text is here. What you can do is you can select one of those rows and click on the SQL ID, and then it's gonna open the real-time SQL monitoring for that SQL ID, where you have many of the SQL properties, including, for example, the time and the weights and also the IO. Now, if you scroll down on this page, you can even see the currently being used SQL plan for this statement. And here on the plan, you can even see which part of this plan is consuming most of the resources and the time. So in this example here, we can see it's doing a lot of merge join Cartesians, which usually takes a lot of time to execute. And usually it's caused by a poor SQL writing here. Okay, there are other tabs like SQL text, activity, and metrics, where you can also see other information about this running SQL statement. In case the SQL monitoring, the real-time SQL monitoring is not helping you to solve your SQL problem, the last resort, which is the SQL trace. That's the same as enabling the 10,046 SQL trace on your statement. So how it works in ADB is a bit different, because here in ADB, we don't have access to the directory of the Oracle home to get, for example, the trace files that are generated by the database. So the way we have to go with ADB is first creating a credential that will be pointing to object storage, and then you set this credential as the default for this database. Later, what you do is you set this default logging bucket property pointing to the object storage bucket. And then with the credential and the bucket set, now you can enable the SQL trace for a session, and we will save the trace of these SQLs on the object storage instead of saving them on the diet folder of the database compute. Okay, so that way you can still generate SQL traces for your statements. In case you have an application that you cannot do an altered session set SQL trace equal to true, but you still want to enable the trace for this application, one way you can do it is creating an after logon trigger on the database, and based on some of the connection properties, you can enable the trace for that session. For example, based on the username, or maybe even on the model or the application name that's connecting on this database. Now back to you, Mike.
Thank you, Rodrigo. This was a good finish for today. And thanks, Daniel, and thanks, Alex. I think we covered almost everything. Not everything, because there's so much more to tell. But it's time for the summer break. And we would like to say thank you for tuning in today. Please remember, try out things, play with it. ADB is not taking away your job. ADB is a fantastic extension making your job easier by lifting off things which cause you a lot of work in your daily basis. Try it out. Try out what we told you. We showed you how to plan it, how to find a low-hanging fruit. You remember Estate Explorer. Run CPAT. Migrate by yourself. Data pump, use our scripts, AMA, let us know if you want them. Use our tools, Zero Downtime Migration, DMS Data Migration Service. There are multiple tools out there, and more may come in the future. And then operate ADB. Tune it well. Trust it a bit. It's a change and shift, definitely. I can tell you by heart by myself, not being able to do certain things is sometimes a little bit like, why not? I know better. Trust the system. Accept that things are handled a bit differently, but at the end of the day, this can ease your life a lot. We wish you successful migrations. Let us know if things work, and let us also know if things didn't work. Get in touch with us. We are still looking for reference customers. If you want to become an ADB reference, coming up with one of the future Cloud Worlds on stage with us, for instance, or to the Global Leaders Meeting, please, we are here. We are here to help. We want to hear from you. Take the chance. Remember, we all block. MikeDietrichD.com, DOHdatabase.com, DBARJ.com.br, and alexabala.com. Here you find a lot of useful information, also for cloud migrations, of course, but for auto upgrade and patching and so much more. Don't forget to subscribe to our YouTube channel. We promise no buzzwords, no marketing information, just tech facts. 2-3 times a week, a fresh video. And then thank you. We are now heading out for the summer break. We hope you do the same. And then we'll see each other in fall, maybe in person at Cloud World in Las Vegas. October 13 to 16, if I remember correctly. And remember, we have a super cool pre-event training. If you're coming to Cloud World, come on Monday already, be there with us for our training session. Thank you so much. Take care and speak soon. Bye.